Hey everybody, quick updated video. Throughout the years, I've come up with an easier way possibly to solve problem 5 that I can't really take credit for. One time a student came and they were like, hey, Miss Langeli, can't we just solve this way? And I was like, whoa, that was actually really cool. I'm going to leave my old video on the lesson if you'd like to see the ins and outs of why this particular method works. But if you're just kind of looking for a short, clean-cut way, new way to solve problem 5. Endangered species. The table shows the world population for Iberian lynx in 2003 and 2004. If this trend continues and the population is decreasing exponentially, how many Iberian lynx will there be in 2014? So we have the first year that it was measured. In 2003, we have 150 of those Iberian lynx. And then in the next year, 1 year right after, only 120. Now, in the year 2025, I do want to let you know that conservation efforts were made, and now we have a population well over 2,000. So pretty cool that you can use math to show you what will happen if somebody doesn't step forward and step up. So kind of a great little story there that these are no longer quite as endangered as they used to be. Okay, again, we're missing the percent. So I want to go through and I really want to point out the main formula. Okay, this is the formula you need to have. It's called an exponential function. Remember, A is the beginning amount or the initial amount. With that being said, initially in my little box over there, we only had 150 Iberian lynx. And then Y is the new amount, right? So it was down to 120. We have no idea what the percent is. We have no idea what the factor is, so we're just going to leave B as B. In fact, I'm going to use a different color because it's unknown. Now, X is how many years went between these two items. So it went from 2003 to 2004. So that's just a difference of 1 year. So your new equation is that equation right there. So when I look at this, kind of tighten it up. That 1 goes with the B. I actually see an Algebra 1 problem now. We can simply divide each side by 150, grab a calculator so we can get it as a decimal, and if it's too terrible of a decimal, we'll change it to a fraction. Divide by 150. So you have what's called 0.8, and that is a vocabulary term for b to the first power. Now make sure again that you're okay knowing that b to the first power is just b. I have a vocabulary term, but I do need to explain something. If this so happened to be to the second power, you would have to take the square root to solve for it, but it was not to the second, it was to the first power. If it so happened to be to the third power, you would have to take the cube root, but it was not. It was to the first power, so it was just the b value. That 0.8, remember, it's less than 1, it's called the decay factor. Because it's the decay factor, you have your whole equation now. It's y equals your initial measured amount of 150, your decay factor, which we solved for, of 8, to the unknown x power. This is the generic equation that you can use to sub anything into. The problem does ask you to solve for the year of 2014. So they're saying, hey, if this trend continues, how many will we have in the year 2014? And again, I want to tell you in the future that conservation efforts were made. So thank goodness this did not happen. So we want to think, how many years is 2003 to 2014? That is a total of an 11-year difference. So I need to plug in 11 for my x. I'm going to do a quick duplicate of my equation, but instead of duplicating x, we are going to put an 11 in here. We'll grab the calculator, and you can type it in one step. There's no reason to do more. And it is going to be predicted that you would only have between 12 and 13 lynx, which is by definition what we have as an endangered species. Now again, if you looked this up right now in the year 2025, there are over 2,000 of them now, but someone used math to predict that, hey, if we don't do something to help these, these links that something bad is going to happen. We're going to be down to only 12 or 13 of them. So that is a quick way to solve that type of a problem. You will use that on 2 homework problems. There's one about a bouncy ball and one about bears. You will use this method. Again, I will leave my old video posted if you want to see a different way of solving it, but throughout the years, kids have said this way is much easier.